where V is equal to minus E1 plus I1 Z1. What is the induced EMF on the secondary? E2 equal to V2 plus I2 Z2. So that is very, very important. So what we are considering, sir? First of all, so I will give the conclusion points here. Conclusions. Okay, first one, what is the conclusion, sir? Permeability is not infinity. This is the features of practical transformer also. While you are attempting an examination, you should read the question twice and thrice. He may be asking for the features of practical transformer or ideal transformer. So ideal transformer is permeability is infinity. But coming to the practical transformer, permeability is not infinity. That means I mu is required. I am drawing the phasor diagram now. So this is I mu is required. And I mu and flux both are in same phase. These are called the induced EMF. Recollect your data, and the angle between the supply voltage and induced EMF is 180 degrees. Then the transformer is also called as a phase shifting device. Okay, sir, permeability is not infinity means I mu is required. I mu is required. And what is the second assumption, sir? Iron losses are not equal to 0. That is practical transformer. What is the second assumption? Iron losses are equal to 0. But while we are considering the iron losses, one more component we added, sir. What is that one more component? What is that one more component where V is equal to minus E1? What is the one more component? Active component of the current, sir. By adding these two phasors, resultant you will get the no load current. The angle between the supply voltage and current is called the power factor angle. Remember, power factor angle is called the phi. Power factor is represented with cos phi. It is a ratio of resistance to impedance. Okay, resistance to impedance. And while we are considering the transformer on load condition, the transformer is on load condition. So this is about the magnetizing component of the current. And next one is E1 and E2 here. And this is our supply voltage where V is equal to minus E1. Minus E1. And this is a wattful component of the current. The resultant is I naught here. The angle between the supply voltage and no load current is phi naught. Once the transformer is loaded, what will happen with respect to V2? Not with respect to E2. With respect to V2, this is for lagging current. Now you understood what is my lagging means. RL load. Okay. If it is a 90 degrees pure inductive load, pure inductive current is always lagging. So with this I2, there is a reflected current where I2 dash is equal to K times of I2, K times of I2. And by adding these two phasors, draw a line which is parallel to I0, draw a line which is parallel to I2 dash, then you will get the primary current. The angle between these two is called the primary power factor angle. From these three, what are the competitive bits are coming? That is your question, right? Okay. So when the permeability is not infinity, that means minimum excitation current is required to produce the flux. The angle between flux and induced, the flux and I mu is 0 degrees, sir. The angle between the flux and induced EMF is how much, sir? 90 degrees. The EMF is lagging only. So coming to the clockwise only. But phasors are rotating in anti-clockwise direction. Anti-clockwise direction. Now, with the consideration of iron losses and not only consideration of iron losses, again we are considering the finite permeability also. This is for finite permeability. This is for to meet the core losses. And suppose if he may ask phasor diagram on leading power factor. So this is for lagging power factor. Sir, why I am trying, sir? Definitely in one of the one of the previous year question paper. So he's giving the phasor diagram. Phasor diagram. This phasor diagram is reference to which type of load? Dash type of load. RL load. RL load. Okay. So I1 is equal to I2 dash and I1. I2 dash bar plus I0 bar. The angle between the supply voltage and primary current is called the primary power factor angle. So if you are going for the leading power factor, so this is E1 and E2, and V2 is also in phase by neglecting the no load angle. See, this is called the watt full component of the current. So this is a no load current here, and now, so this is called the leading. You should remember, leading means RC load, sir. Leading power factor. What is power factor, sir? What is power factor? Cos phi 2 is called the power factor. So I2 dash, where I2 dash here? I2 dash is equal to A times of I2. So add these two phasors now. Now draw a line which is parallel to here. Draw a line which is parallel to this one. And then you will get the primary current. Now the angle will be decreases. What is our conclusion points? With the leading power factor, the primary power factor angle decreases and the cos of angle will be increases. Why, sir? Cos 0 is how much, sir? 1. But cos 90 is how much, sir? 0. Lower angle will be decreases. But whatever the magnitude value increases. Magnitude value will be increases. So this is about the transformer while we are considering all the parameters, okay, except the resistance and leakage reactance. So that is not required for you.